So what is the value of degree of freedom at critical point? The value of degree of critical at point is, because it will convert from liquid to vapor. So again the critical point is a unique point, so we require degree of freedom equal to 1. So at this point is critical point, which is 374, and we have unique value for pressure also 221. So degree of freedom is 1. Saturated water is slowly heated at constant pressure at 200 kilopascal to final state where its quality reaches to 0.65, and data is given to you at 200 kilopascal. Where to calculate change in entropy. So let's say we have TS diagram here, and we have pressure of constant 200 kilopascal, and it is given that the steam attains a value of 0.65. So that point will be inside the dome, and heating is taking place at constant pressure. We have a saturated liquid water, that is this point is 1 point, that is the beginning, and the final point is represented by dryness fraction equal to 0.65. So that will be inside the dome. So during this process your temperature remain constant and is same as Tsat, which is given as 120.23. So T1 is same as T2. We are given the value of HF and Hg, and we want to calculate the change in entropy. So what is required? From that we will start. Recall that we have del Q equal to TdS, or ds equal to del Q by T, which can also written as du into du plus pdv or dh minus vdp. Second equation is better for you because your dp is pressure is constant, so dp is 0. So we have Tds equals to dh, and for this one we can't write dh equal to cp into dt. That is not permitted for phase change, but the temperature is remain constant. So we have ds equal to dh by t. So we can integrate this term now. So if we integrate this from f 1 to 2, so we will get s2 minus s1 equals to Tsat is common, that can be taken common. So we have 1 upon Tsat because of constant term, and we have h2 minus h1. So we have 1 upon Tsat. Now h2 is for wet steam is hf plus x hfg at pressure equals to 200 kilopascal minus hf at same pressure. So in that case your hf will be cancelled out, and you simply left with x2 into hfg divided by Tsat. Now hfg value was indirectly given to you in terms of hg and hf. x2 is also given, Tsat is also given. So we have x2 is 0.65. hfg we can write as hg minus hf, 2760.6 minus 504.68, and temperature you have to write down carefully in Kelvin is 120.23 plus 273, and you can calculate this value and you can get your required answer is 3.64 kilojoules per kg per Kelvin. Now take a note here that if we integrate from f to g, then you have to also write down fg. Temperature at f is Tsat, even at temperature at g also 2 Tsat. So we have hg minus sf equal to 1 upon Tsat, because from f to g your temperature is constant, so it can be taken outside, and this value will be simply equals to hg minus hf. So next time remember this calculation. So you can directly calculate SFG as HFG divided by Tsat, and temperature must be in Kelvin. Water flows through a turbine, and there, because of friction, the temperature of water will rise from 35 to 37. There is no heat transfer. You want to calculate entropy change. Now here in this case we have water, so our Cp will remain constant, so phase is not going to change. So we have ds equal to del q by t, and we can write this as du plus pdv divided by t. Second equation we have dh minus vdp divided by t. Now this time he says that the process is taking place at constant volume, so we can very well write dv will be equals to 0. So this value will be equal to 0. So we have simply du divided by t. So we have ds equal to du. For water, there is no phase change. Cpw multiplied by dt by t. For water, Cp and Cv are identical values. Now we can integrate fit from 1 to 2. So we have S2 minus S1, that is delta S. Cp of water is going to be constant, is ln of T2 by T1. Cp of water you can take as 4.2 ln. Temperature T2 is 37 plus 273 upon T1 is 35 plus 273. Solve this, you will get change in entropy. 0.02718 kilojoules per kg per Kelvin. The entropy of a 7 kg of steam at 3 megapascal and 300 degrees Celsius you want to calculate. And data points are given to you. We are given temperature, we are given HF, we are given Hg and SFG. Now first of all you have to check the condition of steam. The temperature is given as T100, whereas the corresponding Tsat is 234. It means that 300 must be superheated steam, because this value is greater than Tsat, which is equals to 234. So it is confirmed that the steam is superheated. So you have to use the formula for superheated steam. Recall that we have ds equals to del q by t, which is same as dh minus vdp divided by t. Now in this case your dp will be 0 because it's a constant pressure process from saturated to superheated. So we have dh equals to dh divided by t. Now since superheated, we can very well write Cp as equal to constant value, and therefore we can write H equal to Cp multiplied by T. So we have ds equal to Cp multiplied by dt by T, and you have to take the specific heat of superheat vapor, integrating this from G to sup. So in TS diagram, we have a constant pressure line of 3 megapascal. We have T saturation equal to 234 and corresponding temperature of steam right now is 300. So from this point is G point, that is Hg point. This is Ts versus entropy plot, and this one is sup point. So T sup is 300 and T sat is 234. So integrating from T sat to T sup. So we have S sup minus Hg equal to Cp vapor into ln of T sup by T sat. All temperatures you have taken Kelvin. So you simply put this value. We want to find out S sup. We are given Hg equal to 6.19. Cp vapor we can take as 2.1 ln. T sup is 300 plus 273 divided by T sat is 234 plus 273. You can solve this to find out S sup. So final answer is 6.48 kilojoules per kg per Kelvin. And since mass is given 7 kg, we will multiply this. So total entropy S sup is equals to mass into specific entropy. So we have 7 multiplied by 6.48. That answer is very close to 45.36. So choice C is correct. The specific volume of steam after expansion of a turbine is 12 meter cube per kg, and we are given the pressure and volume. What is the dryness fraction of the second decimal place you want to find out? So after expansion we know the volume, and this steam he says that is a wet steam because he is interested in dryness fraction. So we have V equals to 12 meter cube per kg, whereas Vg at corresponding value is 15.25 and Vf is 0.001. Vg is 15.25. Since V is less than Vg, we can confirm that this is a wet steam. Since we are confirmed that this is a wet steam, we can write the formula for wet steam as V is equals to Vf plus X into Vg minus Vf or Vfg only. So it is Vf plus X2 into Vg minus Vf. V2 is 12, Vf is 0.001, X Vg is equals to 15.25 minus 0.001. You can solve this for x2. So we'll get x2 equals to 0.78. That is choice A is correct choice.